Oh my god, guys, I had a nightmare.
Oh, what was your nightmare about?
I also had a nightmare.
So the nightmare right, is about our robot in week 9, it just explode.
Oh my
same
god,
sia.
me too.
Deja vu.
Hey, how come we back to week 1? I thought we just finished with our fastest car competition.
Why our robot explode again? I thought it was a dream.
Oh my god, I think we're stuck in a time loop.
It's probably the explosion.
Go and find out!
So Algo team, please prove your innocence.
For the algorithm simulation, the arena is split into grids of 20 × 20. With the provided coordinates and orientation of the obstacles, it creates a goal position that the robot should be in. We use the A-star algorithm to plan the path to the obstacles. The pink border around the obstacle prevents the robot from taking a route that collides with the obstacle.
We also increase the cost of turning so that the path we turn does not contain too many turns. To plan the shortest Hamiltonian path, we use the nearest neighbor algorithm traversing through the different Euclidean distances to find the order of obstacles that will result in the shortest total distance.
Please enjoy.
The Android relays real-time information of the robot to users via Bluetooth. It is user-friendly and pleasing to the eye. We achieve this by having a consistent theme. First of all, you need to connect to the robot using Bluetooth. Just tap on search and then connect. The obstacles are interactive. Simply drag the obstacles and place onto the arena. Tap on the obstacles to change the facing direction. Simply type the XY direction on the text field. User can place the obstacles on the map. The robot can be controlled by the intuitively placed brakes and pedals on the application. The app will send Bluetooth signals to RPi to control the robot.
We implemented a draggable bottom sheet for better usability and user experience. The bottom sheet dialog consists of 3 tabs: Map tab, Control tab, and Comms tab. In the Map tab fragment, we can set the start point of the robot onto the map, change the robot facing direction on the UI, and also to reset the map. For the Control tab fragment, the Calibrate button will send the obstacle location information on the map to RPi. The Explore and Fastest button will send an instruction to RPi to start the respective task, and the timer will start along with it. Lastly, for the Communication tab, we will be able to see all the instructions that are being sent and received. Upon receiving specific instructions such as a recognized obstacle image and the robot location, we will then update the map accordingly.
For the image recognition, we use RoboFlow to annotate the images and ensure that we covered different angles and positions so that our data set is more robust. For our model, we use YOLO v5 and incorporated majority voting where an image is predicted several times and the most popular output will be the final one. To establish a communication between the RPi and the image recognition server, we make use of socket programming and image ZMQ.
I did a multi-threading code which connects the RPi to STM, Android tablet, and Algo. Following is an illustration for week 8 tasks. First, Android will send a string of obstacles to Algo. Algo will then send the path to STM. The image server will return the image ID to RPi, and then RPi will send the target string to Android.
What about STM?
Did you do anything without me?
No, I didn't. I just changed the variables until the turns were accurate. Oh, I also noticed that the speed of the front wheels were not very consistent on both sides. That must have been why our robot couldn't move too straight. I tried tightening or loosening certain screws to reduce the shaking of the axle as well as correct the front wheel alignment. Other than that, the code was pretty much how we left it.
Oh yeah, we also calibrated the IR sensors for rear and side distance measurements to further improve our design and use the ultrasonic sensor for front measurements, right? Then by adding weights to the robot, it fared much better in terms of movement on all surfaces if I remember correctly.
So it's none of you guys' fault. So there can only be one possibility to end this loop.
Oh shit!